Hello everyone. Uh, Today I will give you an example of on how to solve a system of linear congruences with back substitution. Of course, there is another way besides using back substitution to solve a system of linear congruences, namely by Chinese remainder theorem, but we don't discuss this here. So let's start with this example. So we want to find a solution for x such that x is congruent to 1 modulo 5, and x is congruent to 2 modulo 6, and x is congruent to 3 modulo 7. So how do we find x? So to get the answer, let's start with the first congruence. So from the first congruent, so since we know that x is congruent to 1 modulo 5, by definition of linear congruences, we have that actually x is equal to 5t plus 1 for some t integer. Now this expression for x can then be substituted to the second congruence. So we have that 5t plus 1 would be congruent to 2 modulo 6. Yeah. In other words, 5t is congruent to 1 modulo 6. All right. Now, so how do we solve t then, right? So from solving x, we move to solving t here. So what is t here? We solve this by finding the inverse of 5 modulo 6. So we need to find the inverse of 5 modulo 6. And of course, this inverse exists because the GCD of 5 and 6 is actually 1. Now, we know this, but we want to use this the computation of the GCD to actually get the inverse. So we know that, for example, 6 is equal to 1 times 5 plus 1. So that means, and of course we know that 5 is 5 times 1 plus 0. Hence, we know that 1 is equal to 6 minus 1 times 5. Yeah. So the inverse of 5 modulus 6 is minus 1, or equivalently 5. Yeah, so we check, we can verify that 5 times 5 is congruent to 1 modulo 6. Now, from here, from this fact, thus the equation, the linear congruence of 5t congruent to 1 modulo 6 becomes becomes 5 times 5t congruent to 5 times 1 modulo 6, and which means this is the same as, of course, t is congruent to 5 modulo 6. All right. Now, if t is congruent to 5 modulo 6, then t is equal to actually 6 s plus 5 for some s, for some integer s. Now we substitute t here to the original to x, right? The expression for x, because x is 5t plus 1, which is 30s plus 26. Yeah. Now 30s plus 26. Yeah. For some s, for some integer s. Now, in the next step, we want to also take into account the third congruence. Let's add a space here. Here, now with this, then we can use this expression for the third congruence. So since x is also congruent to 3 modulo 7, we have that actually 30s plus 26 is congruent to 3 modulo 7. That is 30s is congruent to minus 23 modulo 7. Yeah, or let me, and this is congruent to 5. Yeah, 5 modulo 7. Now, similarly as above, then we need to compute the inverse of 30 modulo 7. Now, so we perform the GCD computation. So we know that 30 is actually 4 times 7 plus 2, and then 7 is 3 times 2 plus 1, and then of course 2 is 2 times 1 plus 0. Now from here we get that actually 1 is equal to 7 minus 3 times 2, which is equal to 7 minus 3 times, what is 2? 2 is 30 minus 4 times 7, which is of course minus 3 times 30 plus 5 times, not 5, I apologize, 13 times 7. Yeah, and inverse of 30 modulo 7 is minus 3, or well 4. Yeah. Now we check. We check. Let's multiply 4 with 30. So 30 times 4 is 120. Yeah. And um, and then this is congruent to 1 modulo 7. So we fulfill it. Yeah, so we get that 4 is the inverse for 30. And from here we know that that so that 30s is congruent to 5 modulo 7. Now this becomes 4 times 30s is congruent to 4 times 5. Is congruent to 20. Is congruent to 6 modulo 7. Yeah. And this is S, yeah, is congruent to 6 modulo 7. So we get that S is actually congruent to 6 modulo 7. Now this means S is equal to 7 times K plus 6, yeah, for some K integer, and then X which was equal to 30s plus 26. Now this becomes 30 times 7K plus 6 plus 26, which is of course 210K plus 180 plus 26, which is 210K plus 206. Yeah. For some integer K. Now this means, yeah, by this expression, we know that actually X must be congruent to, well, 206 modulo 210. Yeah, so that's our solution. So essentially any X that is congruent to 206 modulo 210 would satisfy the 3 congruences given in the problem. All right, so hopefully that example clarifies the method to solve a system of linear congruences using back substitution.